Hello, this video will go through some of the topics and types of problems that you're going to see in PreCalculus chapter 1.4. This is a copy of the textbook. I know I've cut some of it off that I'm using. Ron Larson and Paul Battaglia are the main authors of that. So I just wanted to show you that's where we're coming from. Chapter 1.4 is all about functions. You've probably had oodles and oodles of functions. I make this video assuming that you've had Algebra 2, so I'm not going to go into extreme detail for a lot of the algebraic parts. And let's see, for functions, what you want to remember is there is a pretty good definition, a function of f from a set A to a set B, and every x has one and only one y. So that's kind of the best way to remember it. Two other words that are associated with functions is domain, and that means all of the x values, and the range, which would be all of the outputs or all of the y values. So that's going to be a big chunk of what we're going to be studying this year, different kinds of functions. There's 4 ways to represent a function. You've probably seen most of them actually in your math career. Verbally, by a sentence that describes how the input variable is related to the output. So that could be like you cube the value of x and then decrease it by 6. That would be a verbal sentence that describes a relationship. Numerically, by a table or a list of ordered pairs that matches input values with output values. So you know ordered pairs are the numbers in parentheses. You guys are used to tables, I'm sure. The third way to represent a function is with a graph. There's quite a lot of words that talk about that, but graph. And the last way is algebraically with an equation. And again, that's something that you should have seen pretty often in Algebra 1 and Algebra 2. So let's go back to my worksheet here. I'll just go through, this is function notation. The reason why we use it is to kind of differentiate each functions from each other. So if I'm going to be having two functions, in the old days we would have this y equals x squared minus 6 and y equals, well then you wouldn't know which function I'm talking about. So we can label them f of x refers to this equation, and g of x refers to that equation. For each of these, we're just going to evaluate each of this. So for A, they want us to find f of 5. So you go to the f equation, wherever there's an x value, you put in a 5. So you'll have 5 squared minus 6, which is 25 minus 6, and you just get a nice concrete answer of 19. Part B, it tells you to use the g equation this time. So we're going up here, g of 3. So we copy the 16 minus 3 squared, 16 minus 9, and that will give us 7. C is the same idea. They want g of negative 4. So copy the 16, the minus. We're going to square negative 4. Squaring negative 4 gives you 16. So we will get 0. And be careful with that, right? Make sure you square the negative 4, then apply the subtraction sign to it. D and E are just a smidge more complex. Again, these are more Algebra 2 level things, I would say. Let me scroll up just a little bit. So for f of 2x, we're going to go back up here, and we're going to use x squared minus 6. Wherever we see an x, we're going to put in 2x. So it's 2x squared, and copy the rest of that equation, minus 6. We do need to simplify this. So 2 squared is 4, and x squared is x squared. So that would be the evaluation of that. And then this final one, they're asking us to use the g of x equation, and wherever we see an x, we're going to put in x plus 6. So it'll be 16 minus, there's our x, and then we need to square that. So we're going to square out the binomial. I'm going to put it in parentheses for right now, x squared plus 12x plus 36. So if you square this out, that's what you'll get. You'll get this trinomial. And then 16, we're going to distribute that minus sign through. And the last step is to combine any like terms. And the only like terms we have are the 16 and the negative 36. So we'll have a negative x squared minus 12x, and that would make it minus 20. It's totally okay. Another way to write this is negative 1x squared. Some folks really like to see their ones in there. Some people don't. So either one of those is legitimate ways to write that. Let's see. Another thing about functions that I mentioned a minute ago are the words domain and range. So domain represents all of the x values that a function can take, and the range would be all the y values. We'll be studying this in much detail. Again, go through the book in chapter 1.4, look at the examples, read through the words that they have there, take some notes if you want. There's 3 problems here, 4 actually, you can only see 3 on the screen right now, that are going to show you examples of where domains are restricted. It's almost, for all of the functions you've studied in the past, a lot of them, the domains are all real numbers, that x can be any number at all. But there are a few cases where that doesn't happen, and that's what I'm going to outline here. This first one, this is a rational function because we have a fraction here and there's x on the bottom. And so we all know that the bottom cannot be 0. If we have 0 in the bottom of a fraction, we get the function undefined. So what we're going to do to determine where the domain is we're going to find out where the domain can't be. So if we look at this bottom, we have 2 times x minus 3. The part that could potentially be 0 is this. The 2 is just a constant. So what we do is we take whatever's in the bottom, and we know that, let's just set it equal to 0 to find out where it goes to 0. So if we add 3 to both sides, we find out that the value x as positive 3 makes this function undefined. So we could say for the domain, it's all real numbers except x cannot equal 3. Or you could write except x equal 3. Probably if you're using the word except, you should just have equal. Number 2 is an example where it's not a rational function, so what's wrong with it? There's nothing much wrong with it, but we're talking about an area formula. And if you're going to be measuring the area of something, you're not going to get a negative area. That doesn't make any sense in most concepts in the real world. So we're just going to make sure that, I was going to say that r is going to always be positive, but now, you know what? We're squaring r. So no matter whether r is positive or negative, it's not going to matter. So r can be, the domain can be all real numbers. And this symbol here is for meaning all real numbers. Okay, third example, we have a nice function, f of x. We have a square root here. The thing you have to worry about for domains with square roots is if we have the square root, say, of -6, and you put that in your calculator, you're going to get that it's not a real answer. So we can't have a negative number under the radical. So that's what we take into account. Whatever's under the square root or under the radical, we copy it over without the radical. And we want this stuff to be greater than, it can equal 0. Sorry about that. Yeah, so it has to be greater than or equal to 0. So then all we do is just solve this. So if you minus 6, x has to be bigger than -1/2. So this is your description for the domain. So for the domain on this one, x has to be bigger than or equal to -1/2. If you picked, say, -1, let's just double check that. If x equals -1, we're going to get 6 plus -12, and that would give us a square root of -6. Oops, I forgot to multiply. So 6 plus -12. Yeah, that's right. I was getting confused there. So that would give us a square root of -6, and that won't allow us. That won't work. So this is your domain. To me, these are the easiest ones. These are probably the ones that you saw in Algebra 1. This function is defined as a set of ordered pairs. There's 4 points. That's it. So to have the domain, you would just list off all the x values. So the first ordered pair has a -2, 7, -10, and that's the domain. All right, so the domain, and if I asked you for the range would be all the y values there. That's probably good. This is kind of just explaining some of the things in the textbook, so you can't just look at this video and get a grasp of everything. You want to go through the textbook as well. There's also a function that you should have seen in Algebra 2 called piecewise functions. They're a little bit busy. Let me go down here to this document so you can get a picture of what they look like. So here's one example of a piecewise function. What it means is on different intervals of x, the graph has different behaviors. So you can see from like negative infinity up to about +2, it's starting to look like a parabola there. And then all of a sudden, oh, sorry, that was +1. And then between the interval of 1 and 2, it's suddenly a constant. And then from 2 on to positive infinity, it's a linear behaving function. So it's piecewise. It's behaving differently in different sections. Here's just another example of it. They can have as many pieces as there can be. So those are just examples of graphs. Let me go back to these. This is an example of it written down algebraically. And here's how we evaluate it. Here's the function defined. So we go down here. The first one wants us to find f of -4. So we're going to look at these details and say, where does -4 fit in? Is -4 less than 0? Yes, it is. So this is the definition that we're going to use right here. So all we're going to do is do 3 times x. Well, the x value they gave us was -4. For this next part of the problem, f of 1. Is 1 less than 0? No. So we can't use this definition for this problem. For x between 0 and 2, well, 1 is between 0 and 2. So now we're going to use this equation. So we have x plus 1, so 1 plus 1, our value for that is 2. Our third part of this problem, they're saying find f of 0. So I picked this number on purpose because it shows up in 2 spots. But for this part of the problem, x equals 0. Up here, x has to be less than 0. So we can't use this definition. This here says that x can equal 0. So that's what we're going to use. So x plus 1 gives us 0 plus 1. F of 1.5, so where is 1.5? It falls in this interval as an x value. So we'll have 1.5 plus 1. F of 2, again, I picked this just to make sure you can differentiate. You have to really pay attention to what these inequalities are. F of 2, where x equals 2, that's going to be this interval. So 2 plus 1 is 3. F of 5, so where does that fall in? 5 is bigger than 2, so we're going to do 5 minus 2, which is 3, and square that, so you end up getting 9. So that's how you evaluate a piecewise function. There's also, I'm going to put a link to our video. Khan Academy has a couple, like a little bit more introductory video for that I'll post in our classroom, so you can take a peek at that. And then the last part of chapter 1.4 is called the difference quotient. And we're going to go through a problem with that. Difference quotient is rampant in calculus. This is a pre-calculus class, so we're just going to get a taste of it. You can put this in your notes if you want. One of the most basic definitions in calculus uses this ratio, f of x plus h minus f of x all over h. What it is when you do that difference quotient, you are finding the average rate of change of that function over some interval. Ideally, they would tell us what the value is for x and what the value is for h, and that would make the whole process a lot easier because you could just evaluate the function at those points. What we are doing in pre-calculus, though, is we're coming up with a simplified version. We're going to apply the difference quotient, and then no matter what x value they give us or what h value they give us, we can work through it really quickly. So if we go back to our problem, they want us to find the difference quotient of this. And again, this is just a reminder of what it is. So I'm going to do it in stages. I'm going to find f of x plus h, and then I'm going to find f of x, and we're just going to subtract those. So for over here, we're going to do f of x plus h. It's going to be a little bit involved. And what we're doing is we're copying this. Anywhere we see an x, we're taking out the x and we're putting an x plus h. So I'm copying the 4, x plus h squared minus 2, there's another x. Okay, so 4, and then if I square this out, I'm going to get x squared plus 2xh plus h squared minus, I'm just going to distribute that through. And then before the last step I want to do on this part is I'll just distribute through the 4. So I'm just going to skip a line so I have some space. 4x squared plus 8xh plus 8h h squared minus 2x minus 2h. All right, now let's, we have f of x right here. So we're going to take all of this that we just wrote. So f of x plus h minus f of x. What does that look like? Well, it looks like all of this. Is there any combined like terms? No, we cannot. So 4x squared plus 8xh plus 8h squared minus 2x minus 2h minus the original function. Okay, so it's going to be minus 4x squared, and it's minus a negative 2x, so plus 2x. Okay, so we've taken care of this complete numerator. What I'm going to do is clean this up if possible, and then we'll put the h underneath it. Okay, so we have a 4x squared, and we have a 4x squared and a 4x squared, so those will cancel out. I have an 8xh. I don't have any other xh's. I have an 8h squared and no other. Let's see. I have a minus 2x and a positive 2x, so those are gone. And then the last term I have is a minus 2h. So now what I need to do is, to do the full difference quotient, I need to bring this, there should be an h underneath. And you can see that since each term in the top does have an h, we can cancel out. So this will turn into 8x plus 8h minus 2. So that would be our difference quotient. And what we did is now any person can walk in the room and say, hey, let's say that the interval you're checking on is x equals 4 and h equals 10. So that could be the interval. You could plug that in and come up with the average rate of change on that. So the difference quotient is this, I don't know if you want to call it a formula. It's an expression, honestly, that you'll get used to. And what it is it entails a lot of algebra work to put things through. And honestly, it depends on how complicated your function is. So it's not always this busy, but sometimes it's busier too. So it's just a lot of algebra, and it takes practice so you can get confident with it. I think that's all that I have for now. Again, I would suggest looking through the textbook as well. And if you have any issues, just give me a shout.